Yes, class, am I audible? Ali, Jesleen?
Yes, ma'am.
Okay. So in the last class, we started with the organ pipes that were of two types, closed and open. So I think open we have discussed and closed was left to be discussed. Yeah, open organ pipe we have discussed. Yeah, I was at the Laplace correction. So basically, there initially Newton gave a formula, V is equal to P by rho, under root P by rho. So this was invalid. When Laplace made the experiments, he noticed that this coefficient, if it is multiplied to the pressure, then everything sits well. So he put this formula, he postulated this formula, and this formula was accepted. So this formula is accepted, which is V is equal to gamma P by rho. So if a question comes where pressure and densities are mentioned, you can use this formula for the organ pipes. Okay, so we discussed few things about the closed organ pipe and open organ. Now, the first harmonic I've already told you, harmonic means the first one, n is equal to 1. So for this, you use the formula 2L by n. See, this one. This heading is for the open organ pipes, okay? So just focus on this segment. So if you put n is equal to 1, you will get it as 2L, that is double the length. So when you're talking about open organ pipes, they are open from both the ends like this. See, it's like you take a pipe, you cut it, take a smaller segment and observe one wave. Like this, one wave will be formed. So in the center, you will get one node. Here you will get one antennode. So point of zero displacement node, point of maximum. Here also you can take the antinodes. So n is equal to 1, you get 2L. Similarly, frequency also you can put, and gamma you already know, Cp by Cv. We have done this a lot in the adiabatic. Now this is the fundamental or first harmonic. As we discussed, second harmonic is the first overtone. So this we have already discussed how we write the fundamental and harmonic. First one is always the fundamental. That is the first harmonic wave. Second one becomes first overtone, which is the second harmonic wave. Like this goes on. So this is the same thing. So here wavelength will be L, frequency will be 2 times 2 by L under root gamma pi rho. So this means this is 2 times the initial frequency, 2 times the fundamental frequency. What is gamma 1? This is the fundamental frequency. Like this, see, one wave here and second wave here. See, this dotted line I've just shown to show you that how it will appear for 1 and 2. Otherwise, this is in a continuous manner. Look like this. So this is 1, this is 1. So see, 1 node, 2 nodes, 3 nodes, 3 antinodes. So here it is reverse class. Number of nodes here will be n only. And here the number of antinodes will be 1 greater, n plus 1. Okay, write it, then we'll see closed organ pipes. Okay, class, coming to closed organ pipes. So here the stationary waves equation is 2a sine kx cos omega t c. Wavelength we write 4L by 2n minus 1. Okay, or 4L also. 4L 2n minus 1 basically. That is what we write. For frequency, what we do for nth, 2n minus 1 by 4L, then the Laplace correction gamma p by. So this is also written as 2n minus 1v divided by 4L. We also use that 2, only 2. So, but it's better if you use this formula for a closed organ pipe, okay? Frequency and wavelength. Now see, for the first harmonic or the fundamental, see, closed organ means one side is closed and the other side is open, like this. So this is how the first wave will be formed. So when you put in the value of n as 1, you get L as lambda 1 by 4. And frequency, you get it as V by 4L. So that's what I was telling you initially, that this is NV by 4L. Okay, because this is the nth one. So look like this. One node with one antenna. See, now for the second one. One wave, second wave. See, here this is one, this is second. So this becomes, if you put in the value, lambda becomes 4L by 3, L becomes 3 gamma by 4. Okay, so like this, you can continue this and get all the values. But see here, number of nodes and antinodes both are same. Nodes is equal to antinodes, which is equal to n. This is what you need to remember. Again, first overtone means second harmonic wave. This you need to remember. Okay, we'll see a question based on this. Have you understood? Ali, Jesslyn, is it clear? Okay, write it. Okay, look, class, this says that a pipe 30 centimeter long is open at both the ends. So this is an open organ pipes case, which harmonic node of pipe is resonantly excited by 1.1 kilohertz source. So, and you have to find out, will resonance with the same source be observed if one of the pipe is closed? Means if it is a closed organ pipe, find out n. If it's an open organ pipe, find out the value. So see, for open organ pipe, frequency is NV by 2L. So see, frequency is given as 1.1 kilohertz. And we don't know V, speed of sound. This is given as 330 meter per second. L, length is given 30 centimeters. 10 to the power minus 2 meters. Okay. So here, if you put in all the values, 1.1 into 10 to the power 3 is equal to n into 330 divided by 2 into 30 into 10 to the power minus 2. So from here, you can get the value of n as 1.1 into 10 to the power 3 into 2 into 30 into 10 to the power minus 2 divided by 330. This will be most probably 2, second harmonic function. But please cross-check someone while writing second harmonic function. Now, if it's a closed organ pipe, so frequency is equal to 2n minus 1 V by 4L. So you can put the things. This will be 1.1 into 10 to the power 3. 2n minus 1 will remain as it is. This will be 330 divided by 4 into 30 into 10 to the power minus 2. When you'll calculate the value of n, you'll get n as C. You'll be left with 2n minus 1 is equal to 4. So your 2n will be equal to 5, means n is equal to 2.5. Now, is it possible 1, 2, 3 out of all the integrals, how can we get 2.5? So no, it means it won't resonate at this. So the question, will it resonate? The question was, will it resonate? So it won't resonate. Okay, write this question. Question you all have written? Write it. Okay, class, last topic. What is meant by beats? So see, when two sound waves are there, okay, and they're traveling with different frequencies. Let's say this is one sound wave. This is traveling with some frequency, new one. And this is another sound wave. This is traveling like this with another frequency. Now, condition is that along the same. They are traveling along the same path in the same direction in a medium that superimposes. Okay. So at any point, see the intensity of the resultant sound, this resultant at any point rises or falls. Okay, alternately with time. It depends on certain conditions that those loading and filling conditions we'll discuss. So it depends on that whether the frequency, the resultant's frequency will rise or fall. So ultimately, this is the resultant. So it forms like this. These are the beat frequencies that are formed. Now let's come to the definition. This says that the periodic variations in intensity at a given point due to the superposition of the sound waves of slightly different frequencies traveling in the same direction are called beats. So traveling in the same direction, okay, they are along the same path, along the same direction. Now, how do we calculate these beat frequencies? It's very easy. Easiest formula in your entire physics. Beat frequency is basically, it's equal to the difference in the frequencies. It's equal to the difference in the frequencies of the two superimposing waves. So basically your beat frequency will be nu1 minus nu2. That's it. Now, there are different conditions for the formation of beats. Now, when we are talking about conditions that increase or decrease it, so remember, if the beat frequency is decreasing, okay, suppose on waxing, there's a condition that is loading. Let's take the example of loading, okay? The example of loading. Loading means you are attaching some wax to the prongs. Basically, all these experiments are conducted through the help of tuning forks. So if you attach a little wax to it, what happens? If the beat frequency increases, okay? If the beat frequency, or let's talk about decreases first. Let's say two waves have superimposed and the resultant one has decreased. So if it decreases due to loading of the prongs of the tuning fork, okay, if it is decreasing due to the loading, means you are adding some more wax, okay, And this tuning fork has unknown frequency. Of unknown frequency, right? Then how will you, this unknown frequency, na, this is greater than the known frequency. Let's say nu2 is unknown. Nu2 is greater than, let's say some B constant is there, this much greater than this. Then you can calculate the B. And secondly, if it increases, okay, same thing you're going to use. If the frequency increases, this would increase the beat frequency. So same thing, this nu2 will be nu1 plus, nu1 minus b, because it would be less. So this time it would be lesser. So this is how you have to use the formula, whether it will be nu1 minus nu2 or simply nu1 plus nu2. This is how you have to calculate. Second, one more thing, there is filling method. This is the loading. This one was the loading. Next is filling. Now in filling also, filling means you have filled the tuning fork, second tuning fork, the prong of the second tuning fork with something. So what happens? Frequency increases. So if let's say the frequency increases, so you have to note the number of beats reduced first. If on filling the prong of the second one, if beat frequency decreases, then your nu2 is equal to nu1 minus b, opposite. Okay. Second, if beat frequency increases, your second frequency will be nu1 plus b. So you have to remember this. Okay. This is very important. So if the prong of the tuning fork is filled, its frequency increases. If the prong of the tuning fork is loaded, frequency decreases. Am I clear? This is for the fact that you have to use minus and plus sign. Yes, Ali, Jesleen, am I clear till here?
Yes, ma'am.
Okay, write it till here, then one question we will do and this chapter will be over. Look, class, this question says that a fork of unknown frequency, when sounded with one of the frequencies, it's 288 hertz, gives 4 beats per second. And when loaded with a piece of wax, it again gives 4 beats per second. Why? So basically, we have studied unknown frequency. This is equal to the known frequency plus minus the beat frequency. Now, it will either be, see, 288 plus minus 4 if you do. So it will be either 292 or 284. 284 hertz. So now you have to pick one of these. Is it 292 hertz or is it 284 hertz? So what's the question saying? As the beat frequency remains unchanged. Here beat frequency is unchanged. It's not increasing or decreasing. We have studied the cases where it's increasing and decreasing. So if it was increasing and due to, see, we have seen for the prongs filling case, for the prongs filling loading with wax case. So you could easily pick plus out of plus minus. Now in this question it is saying it is remaining unchanged even on loading the fork, right? Of the two possible frequencies, one must be initial frequency, right? And the other would be the final frequency. C class. One out of both of these, one would be initial, na? That's why, no, when you're taking the differences between the two, 292, 284, sorry, 288 with 292 and 288 with 284. With both of these, you're getting the beat frequency as 4. So out of both the possible frequencies, one must be the initial frequency, another would be the final. Now, frequency of a tuning fork decreases on loading, right? It means that this initial frequency must be higher, that when you are adding, subtracting, doing with whatever this beat frequency, you are getting a lesser value. So 284 cannot be taken. 284 minus 288 cannot be done, but 292 minus 288 can be taken. So your resultant will be 292 hertz. Why is this? Since the beat frequency is remaining unchanged, you will go by the normal phenomena which we have studied, that the beat frequency of tuning fork decreases on loading. So you're going to choose a higher value. See, lower value will, if it was increasing, then we would have taken this, a lesser value giving rise to a higher value. But right now something is decreasing, so a higher value giving rise to a lesser value. Is this question clear to both of you?
Yes, ma'am.
Jesleen, Ali, it's clear to you too? Okay. Okay, great. Please write this question, class, then I'll end the class. This completes with your syllabus. Whatever doubts, queries you have, please gather them. We'll be discussing it. If completed, you both can leave, okay?
Thank you, ma'am. Bye, ma'am.